Several types of antibiotics inhibit bacterial protein synthesis. The 70S bacterial ribosome, which is composed of 30S and 50S subunits, is sufficiently different from the 80S ribosomes of eukaryotes to make it a target for selective toxicity. Most antibiotics bind either to the 30S or the 50S subunit of the ribosome, thereby interfering with protein synthesis. Aminoglycosides such as streptomycin bind to a protein in the 30S ribosomal subunit and interfere by inhibiting protein synthesis and causing misreading of the mRNA. Different aminoglycosides bind to different target proteins on the 30S ribosomal subunit. These antibiotics distort the ribosome so that misreading of the code in mRNA occurs and protein synthesis cannot continue. Bacteria can become resistant to aminoglycosides by mutation of the target ribosomal protein. The tetracyclines inhibit protein synthesis by binding to the 30S ribosomal subunit and inhibiting the binding of aminoacyl tRNA to the A site. In contrast to streptomycin, they do not stop the ribosome on the mRNA, but distort the ribosome so that the incoming aminoacyl tRNA can no longer bind properly to the A site. Bacteria become resistant to tetracyclines by developing an efflux mechanism that removes the tetracyclines from the cell. Some utilize a protein that binds to the ribosome and prevents binding of tetracyclines, and some strains of Bacteroides become resistant by chemically modifying the tetracycline so that it does not interfere with protein synthesis. Erythromycin, a macrolide antibiotic, binds to the 23S RNA found in the 50S ribosomal subunit and inhibits peptide chain elongation. This binding results in release of the peptidyl tRNA. Bacteria become resistant by producing enzymes that alter the erythromycin so that it can no longer interfere with protein synthesis.